What's up, guys? Shawnthebro here, and today we're going to be going over complex hurtboxes. I like to call them complex hurtboxes because we are going to be covering both types of hurtboxes throughout the series. The reason in particular that we're going to be doing this is because I've gotten a lot of requests for if we want a special type of hitbox, or excuse me, a special type of hurtbox. So this is the hurtbox that we normally have, and quite frankly, it is the hurtbox that I will probably be using throughout the majority of the series, where we have this box associated with us, and we have these, we can modify the components, such as shrinking them down, increasing their size, and all of this stuff. And it looks pretty good. I'm very happy with it, and we've covered how to attach this hurtbox and all, but we have some other things in there that I've done for kind of shrinking the hurtbox and different things like that are useful. Today we're going to be kind of leaving this regular hurtbox alone. I will be covering more logic on these simple hurtboxes like most games like Street Fighter use in the future. We're going to add throw boxes and different things that indicate where the character can actually be hit for certain actions and different things like that. But for today, we're going to be covering complex hurtboxes. So I wanted to point that out so I could show you the difference. A lot of you have been asking me, how could we use hurtboxes that are more in tune with what the character actually looks like as opposed to boxes if we want to? And this is used in a lot of the true 3D fighters where you have these three-dimensional battlegrounds. And I apologize because I did not make the hurtboxes visible. So let's do that so you can see them. So these are used a lot of the time in, like I said, more complex fighting games where it's very specific what parts you want to hit and different things like that. Now, at first glance, I did not obviously go through and actually make the hurtboxes where you would expect. So if you're actually going through and doing this and you want to have this complex model with these complex hurtboxes, then you're going to want probably physics assets and different things like that. What I did was just throw some shapes together to show my point and to kind of show different things that you can do with them. So obviously don't take the actual appearance of them as, incorrect or anything like that. I just did this through basic shapes. You would normally want to trace this, or if your character is not so complex and ragged, if it's very easy to identify the shape, then you can obviously do that a lot more easily. But what I'm trying to show here is I have these different hurtboxes that I've placed around the character's mesh, different points, and I've attached them. So as their bones move, they also move. It allows me to move more freely and not really have to worry about anything with the hurtbox. If you can see my character here, then I am also here. Now, it doesn't care if your animation has any sort of root motion or anything like that. The hurtboxes are tied to the mesh in this case. So this will be very, very useful if that's the feel you're going for. It's not quite the standard 2.5D fighting game hurtbox method, but I did say I'd be covering it, and I think it's useful, and I think it's something fun we can experiment with, if nothing else. So the other thing with this is that we can toggle it on and off. I have not enabled or disabled any particular one. I have all of the logic being configured by a Boolean variable. So we can also just leave this in if this is something we want to practice with, if we want to go into practice mode in our game, or if we want to grab data for any reason by doing this stuff. So this can actually be useful for things other than actually using them as the hurtboxes in the game. So I think it's a very important episode and technique, and I think we can cover it here. So let's get started today. There's not too much that we have to do in terms of the code. All I'm going to do in there is add one variable. I am going to change around the tick function to also support some of the things that we did to make them look right when we change directions. But other than that, everything's going to be the same. So first of all, in the fighter template game mode.h, or basically your base game mode code class, I've added a Boolean. I've added a Boolean called is using complex hurtboxes. And basically this is just our toggle. Like the other things, this could be a setting that we want to enable or disable. And since this is a template, and a tutorial series, you know, it's fine if you want to skip this, but in this case, it can be both. It can be either one or the other, and players and users can toggle it on and off. So I have is using complex hurtboxes a boolean in here. This way we don't have to remove our old hurtbox logic or try and change it or update it like that. We can keep everything and we can have the best of both worlds. In the fighter template game mode.cpp, I set it to be false by default so we can use the simple standard hurtbox if we don't change anything in the blueprint. You don't have to do anything else in here. And like I said, I do have some things that we have to change in code in the tick function, so I can scroll all the way down to the tick function now. But it's not really going to be useful to do this now before you add the things in your blueprint, so we'll look at that when we get to it. If we go back to the editor, let's focus on the important parts first. So first things first, we are very far along in the series. I believe this is episode 78. It might even be 79. So if you want to catch up with everything we've been doing and just kind of check it out, then I'll leave a link right here to the playlist. You can catch up on all the episodes we've done and how we've gotten here. I will also leave a link to this episode right here. This episode is important for adding new characters, which I'm going to be talking about using the base character BP here, which essentially is this parent blueprint character class. It's a child of our code fighter template character class, and all of our actual characters, our character BPs, are children of this base character BP class. So we're going to be doing pretty much everything in here, but this is so you don't have to update the logic for every single character. You can update the logic one time and then toggle it on or off on the game mode, and all characters can work with this logic. All right. So to get started, let's go to our base character BP. If you only have one character, you don't have a base character BP, it's also okay if you just want to go to that character. What I've done so far in the series was on begin play of the character, I got the game mode, I determined the player, if it was 1 or 2, set the correct references for if we're playing on keyboard or controller, and then I was doing logic to spawn the hurtbox here. And we're still doing that. But I made a function called spawn hurtboxes because I wanted to separate, depending on the game mode setting, I want to separate the logic. We don't need to spawn both types of hurtboxes. You know, it can be weird enough that we're going to be dealing with two different types where you can have the simple and the complex, but we don't want to have them both at the same time. So I've made a function called spawn hurtboxes. You can hit plus function, call it spawn hurtboxes, and go into it. Now this bottom part I'm not going to really cover because it's something that I've already gone over in the series, but I will glance over it, but we won't go over it in depth. So basically how I was spawning the hurtbox before was I was getting the transform of our actor and spawning a hurtbox actor BP, which is another class I have. I was setting it to something called the main hurtbox reference and adding it to my list of hurtboxes or my array of hurtboxes, and then attaching it to the character. The reason I was doing all these different things was because I was messing around with some of the potential hurtbox logic for simple hurtboxes. So I was setting it to main hurtbox reference because we also want to have throw hurtboxes and different things like that, where you can only be thrown if the thrown hitbox collides with a throw hurtbox. And then I was adding them to the array of hurtboxes just because we want to keep track of all of them and attaching them to the actor. I was then determining if we want it to be visible or invisible, which should also be a setting in the game mode, but it's more for practice once we get to that, and we haven't gotten to that yet. So this is all the same stuff as I have been doing. So you can go ahead and copy that if you don't have it, if it's not up to date, but you don't have to. That's up to you. The only thing I've added here was this, and you can do this now even without adding anything to our character. Basically, for the complex hurtboxes, the way they're going to work is we're going to attach components to our mesh. That way it follows where the mesh is at. So it's basically the most accurate representation you can get of collision without going into very, very advanced specific stuff that's honestly way too hard on the engine and the game anyway when you're playing it. This is going to be updating with the mesh, so what the player sees on screen is what they have to deal with. Now, all I'm doing is I'm doing mesh, get children components, and I'm setting the visibility to false. Now, if you want to add more things like hats, you know, something to your character's face as part of their adjustable character design, so if you have a different outfit, then you'll want to make sure that this is a hurtbox before doing it. Right now, since we don't have anything else in there, it's perfectly fine to do that. But don't worry, I also show you the method of how to do that right here in this new function. So this is all the basic stuff, all right? Basically, add this to the end of where you were spawning your simple hurtbox, and you'll be caught up. Everything else after this is going to be new and adding on to new things. So now I'm doing this within the spawn hurtboxes function, and how I get to that logic is very simple. I have my game mode reference, which is something we already had in our begin play of our base character BP. So this isn't anything I had to make for this. I'm using that to check the is using complex hurtboxes variable, which is false by default. And if it's false, then I go through the normal logic we already had. So you should be all caught up at that point. Now we're going to get into the new stuff. So we're going to get into set complex hurtbox details is what I called this new function. So if you make a new function, go into it. And this is where I set all the logic for the new hurtboxes. So we haven't done any of this before. And I'm going to show you how we can actually grab the child components and make sure that they are part of our hurtboxes and not just random outfits and different things like that. So in this function, I'm getting all the children components of my mesh again, and I'm looping through them. I'm casting it to a static mesh component because I want to make sure this is what it is first. This is what I'm going to be making my hurtboxes that I attach to the mesh type of. They're all going to be static mesh components. So if they're not that, we can safely assume they're not the hurtbox. They're not one of the hurtboxes. But I'm also going to drag off of it and get object name, just like this, and drag off of that and type contains. And you want the one that says string. String contains. What this will do, it will check the string, so the string of the name, for this substring. I'm putting in HB because I've put all of my components, my static mesh components that I've attached to the mesh, as the name that I wanted, and then HB. If you wanted to be really specific because you're concerned that you have, multiple objects that might have this substring, make sure it is something that nothing else will have. So I have collision HB. And now I'll just make sure if I want to attach anything to the mesh regarding outfits or any other reason that I may want to do this, I don't have the substring collision HB in there. And if I don't have that, then this branch will fail out and it won't get added to the hurtbox array. Now, I don't want to confuse anyone, so let me show what I'm doing here. I had this hurtboxes array. I had this, it was called hurtboxes, and this is how I was handling simple hurtboxes. Well, now we're going to be handling these complex hurtboxes, so I didn't want to use our standard hurtbox actor that we have, or our hitbox actor that we have. I actually wanted to use a static mesh component. That way I can just attach it to the character and see it in the character BP. By making it a simple type like a static mesh component, then I don't need to worry about all the extra things that come with the hitbox or hurtbox actor. So I can simply create this variable in here in the fighter template character or your base character, and then we can add to this. So I have two different arrays. This is intended. I didn't want to confuse anyone, and if it is confusing, we can think of it like this. This is simple hurtboxes, and actually I should have written this down, so I'll do this now. Simple hurtbox array, and then this is the complex hurtbox array. And I will go ahead and change the names to, this won't update until after we close this. But normally I would cut this out, but I actually want to show you this because I don't want any confusion. So you can see I made the change here. So hurtboxes has become simple hurtboxes, and we'll call it simple hurtbox array. And this one, the complex hurtbox array, is now called a complex hurtbox array. All right, so that's the difference here. All right, but basically just add an array of hurtboxes. If you want to have both types like me, then yeah, have 2 different arrays. There's no reason that we should be adding these to the same array. I mean, we can, it doesn't hurt anything, but I like to keep it completely separate since I'm supporting both versions here, simple and complex. Then I don't see the reason to try and mix them. That makes it even more confusing than it already is by having 2 different types of hurtboxes that we can use in our game. So I will go ahead and build this, and then we will work off these names from here on out. So give me 1 second, I'll cut, and we'll return when this is built. Okay, we are back and we've built now. So now everything has been moved to simple complex simple hurtbox array and complex hurtbox array. As you can see in the logic that we just showed earlier, the simple hurtbox array adds the simple hurtbox. And in our new function, set complex hurtbox details, I'm now using the complex hurtbox array. All right. So to wrap up what we were doing here, since we got a little bit distracted, we were essentially checking through our hurtboxes attached to our mesh and adding them to this array. Now they are in the complex hurtbox array, so we know what to check collision against. That's all we need to do in here. We just need to make sure that they are tracked. That way we can check collision against them. I mean, we technically could skip this and just check this every time, but it's kind of annoying to keep tracking and locating the same data every time. It's better to have it in some space where we can quickly and easily access it. And then after this loop completes and they've all been added to the array, I also go through and set the visibility to whatever I want. Now this will also be a setting, like I said, probably in practice mode or something like that, to enable hurtboxes and hitboxes. But for now, I'm just setting it to a value of true or false by clicking this value. So I grab my complex hurtbox array, I loop through everything, and then I set the visibility. If it's checked, that means true, which means it is visible. All right. We can leave these other functions alone. These are other functions that I did work on in the past and I have kind of shown off, but they're mainly for the simple hurtboxes. The only reason that they are here is because I made this change and we don't always have a main hurtbox set now. You may want to do a validated get if you copied this logic early on. That way you don't get an error or crash because this data is null and you're trying to use it. However, we will be covering, again, more with the simple hurtboxes in the future, so don't worry about it for now if you don't have it. All right. Now if we go back to our mutant BP, and I'll need to change all these references here from hurtbox array to the right variable. But here, you can see we're not doing anything in the mutant. Just like I said we want it, we really just use these character BPs to hold the appropriate data, such as all the default values for everything and the new mesh. So in each character, and it could be different for every character how many you have and what hurtboxes you have to apply to what character, but I've done this very quickly. I've just clicked on my mesh, add component, and then add a static mesh component, just like this. Now, I've already done this a lot. This is how you get it on here, so I'm going to delete this one. And then you rename it, so call it head collision HB or whatever you would like. And once you have these in here, it's very simple. You pick the type of object that you want. This is where I was saying, you know, for more complex objects, you'll probably want to have the hurtbox shape and not necessarily arbitrarily make this. I just use the cube because it's easy to see. It does look a little funny, but I thought for the purposes of the tutorial, it would just also kind of showcase what we were doing without making things so complex. I'm literally just applying a cube on this guy's head. All right. Whoops, I didn't mean to move it. That's it. Now, all you have to do is select the static mesh and you can select your material. Well, I already have a hurtbox material that we made earlier in the series, so I'm going ahead and using that same material. Once you have that, you're pretty much done. You just need to get it in position in the right size. What I did was I actually clicked on the search here. If you click on this, it will show you the sockets or bones that you can attach to. You can make sockets if you'd like. I straight up attached these to bones. This first one was attached to head, and then I resized and scaled. You guys probably know how to do that by now, but you can literally click on the object, move it around, scale it up and down, just like that. And you just make it to the shape that you want. I didn't do anything special for it, so there's nothing that I really need to show here. I probably should actually move that back. There we go. Nothing I really need to show here, just essentially I've moved the collision boxes to where I want them. So I have one for the head. I have one for the arms, but I didn't go the whole way for the arms. That's his left arm. So for the left arm, I actually only went to before this claw thing because I thought maybe that's where I want the collision to be. If we're going for a specific collision, that's the main reason you do this, because you want it to be very precise, or you want to know what part of the body that you hit, because you can actually gather data about which hurt box you collided with. Then you don't, you can kind of configure this as much as you want. You can add more shapes, you can add circles and other things like that. It doesn't have to be as you don't have to make it as quickly as I made it. You can make it look a lot neater. But you can see the arms don't go the whole way. The chest, I have it expand out past where the chest actually is, because I thought that is how it should look. And then the legs are the same. So I have them at two different points. I have one for the thigh and one for the leg, because if I have this as one static object, if the legs bend, like when kicking, then, it looks bad. It's trying to, it will cut out part of the leg. So anytime you have a spot that'll really bend a lot, you may want to skip that and instead separate into two. And you could easily connect these. I didn't, again, to show you guys. Like, you can easily make it larger. Well, the snapping value is a little high. But you could easily click on this and then select the scale that you want through here and just make it bigger, smaller, just like that. But I wanted to show you that these were all different pieces. So I've added all these, got them where I wanted, and got them on the sockets they want. So I have, my chest was on my pelvis socket, the arm goes to upper arm left, upper arm right, thigh left, thigh right, and calf left and calf right. I have my hurt boxes there, and the base character, remember, the logic we did in the base character for this, the set complex hurt box details, we were adding them to the array. It doesn't matter how many we have. We don't have to arbitrarily do this for each character. We just get all the children components that the mesh has of that character. The mutant has 6, I believe. He's got 8, actually. So there'll be 8 of these. If you have a character that's more advanced or less advanced, then they will have the appropriate amount. That's all we have to do in the mutant. We just set that up, or for every character, we just set that up. You will want to set this up for your other characters, because obviously they won't autofill where they should go. That's up to you. You're the one determining the collision. So you have to do this on the mannequin and other characters you may have. I do have the set complex hurtbox details. Since this is a function, then I can go ahead and access it in a child class if I wanted to. But in this case, I don't really need to. There's no real need to do this. If you do want to set it up where you override it, then you click override in the child class, and you have all the functions that your parents and your hierarchy has access to. So I already overrode it. That's why I wasn't there. But you can see it would normally be here. So I did that to show you guys you can do it if you want, and you can go through and add these if you don't want them as children of the mesh. So if you want to add them manually for whatever reason and just have them as other things tied to this mutant BP character, you can do that too. But I don't really see a need for it. I just want to keep your options open. So you can completely ignore this if the method that I mentioned previously is working for you. Also, one more thing to note, make sure that your static mesh components, all of the static mesh components you have for each of the hurt boxes is set to be overlap all, and generate overlap events is clicked. These are both very important, otherwise you'll have collision of your hurt boxes on your character, and we don't want that on simple hurt boxes or complex hurt boxes. The last thing we need to do with this now is make sure that our collision is actually working on our hitboxes, because we had the simple hurtbox before and we were checking if a regular hitbox collides with it, but it's a little bit different now. So it's the same basic stuff. If you're familiar with our check collision function, it's the same basic stuff. It's a little uglier now, but you can see this bottom path. Okay, we determine player, we determine which player it is, and if this player can deal damage to the player that we're colliding with, right? Now, ignore this branch and just go down the bottom path. We check if the player is valid that it's colliding with. We check our hurtbox array, which I've now renamed a simple hurtbox array, but really it's the same thing. I'd make sure that the hurtbox at that index is valid. If it is, I make sure that it is overlapping this actor. And then if that is also happening, we determine the type and perform the logic from there. So I haven't changed anything here. I haven't changed anything here with the simple hurtbox. I've just added a case beforehand for complex hurtbox collisions. So let's follow it from the start. Check collision goes into determine player, which goes into a branch to determine if it's player 1 or 2. At this point, I branch off. And normally I would get the base game mode reference, grab the player, and check the hurtbox array. But before we want to do that now, we have to drag off the base game mode reference, grab our is using complex hurtboxes variable, drag that into a new branch, and then we want to make a new function, which I can organize a bit better like that. And we want to make a new function called check complex collision. Go ahead, plus function, and make this. Give it an input parameter of your base character, so fighter template character for me, and call it player reference. And then have it an output parameter, just by hitting these pluses, of a boolean, has collision occurred. This is a little bit different than just checking the overlap. Like, for the simple hurtbox collision, we literally check the hitbox against this hurtbox, and if it collided, then great, we're good. But this is a little bit different because we do have to know if any of the hurtboxes were collided with, and also we don't do it here, but if you wanted to be more specific, when we determine that a collision occurred in this function, you could also save out the one that it occurred to and perform different logic. So if it's true that is using complex hurtboxes is enabled, then instead of doing the simple logic, we go into this function. We pass it the player reference, so the player that we're checking against. Remember, we determine the logic and then say, oh, we're player 1, so we want to only be able to hurt player 2. So pass in the player 2 reference. I have some reroute nodes here, but if you follow it, you can see that player 2 is the player reference being passed in. Otherwise, if we're checking against player 1, you do the same thing. There's no curveballs here. Player 1 gets passed into the player reference. You can see these are exactly the same. They're just separated by player 1 and 2. All right. Now let's go into check complex collision before we do anything else. So go into this function. And here's the entire function. I'll zoom in a little bit so you can see it better. But we have this player reference input parameter that we added, and this is player 1 or 2. We use this because we can grab their hurtbox array. In this case, we want the complex one. Then we want to loop through every hurtbox in here. So just drag off of this and do for each loop with break. We want to be able to break out of it to save us some time if we determine a collision occurred. If we don't care about the specific components hit, and we only care about either the first component hit or if a component was hit like we do here, we don't really care which one, but just if one was hit, then we can break out and save us a lot of time looping through these. So in loop body, skip all this stuff for now. This is what we'll do when the loop is completed. In loop body, we drag off of array element and we check is overlapping component. All right. Because we're going to check against the hitbox display of this mesh. The hitbox display, if you're not aware, is the static mesh of the hitbox actor that we are spawning. The reason this is important is that's the area we want to check. We could do is overlapping actor and just do self, and that's also fine. But is overlapping component is just a little bit more specific. So we drag off of the array element. We check if it's overlapping with this hitbox. So is that hurtbox overlapping with this hitbox that we're currently in the class of? If the branch, and obviously that goes into a branch, if that evaluates the true, then I have a local variable that I set to be true. That way we can then return that value. So to make a local variable, down at your bottom when you're in a function, you can't do this in the event graph. When you're in a function, you can hit plus local variable to add one. I called it collision occurred and left it a Boolean, or made it a Boolean if that's not your default. And I set it to be true if this branch is true. We don't really have to set it to false because it has a default value of false. So, if we never set this to true, that means no collision occurred. If it does get set to true, then a collision occurred. So set it to true, and then you see I do this weird thing. This is because to break a for each loop with break, you have to bring it into this slot right here, this break slot on the front. So now we've said, okay, collision occurs. We no longer need to loop through the other elements. So I've brought it into here, just like that. But then I've double tapped. You can double tap anywhere on any of these lines to make a reroute node, which are these little circles you see. And you can move them around to move the whole line. So I'm going to undo that. That way things go back to normal. But I've just added some reroute nodes so this looks a little bit better. But we're just breaking out of the loop so we don't continue looping through this since we know a collision already occurred and we can deal damage. Then, since we've broken it, we'll go directly to the completed logic. So all we have to do now is add a return node. Since we have an output parameter in our function, then if I click on this, then it will have a return node available. You just type return node, and it will have your output parameters. You could arbitrarily select this, but since we have the Boolean collision occurred, I would go ahead and fill that in, because if it doesn't occur, we want to know that no collision occurred, so we don't want to deal damage. And that's what this is here. All right, so that's the whole function. And that checks if we've collided with any of our complex hurtboxes. Now, if we did, this goes to a branch. All right, so you drag right off the return and bring it into a branch. If it's true, that means there was a collision. So we skip all the simple collision logic, and we go directly to the switch on hitbox enum, and it proceeds as normal. It'll go through, determine the hitbox type, and perform the logic correctly from there. It's the same exact logic for this player. Has collision occurred, branch, go to the switch. And then the only other thing we may want to cover for this is to make the complex hurtboxes look a little bit better. If we're using our standard flipping logic here in our tick function, what we were doing was going through and checking if the character was flipped or not, which I've now changed is flipped to be called is facing left, just because is flipped was too hard to keep explaining every episode. So is flipped for me basically meant, are they facing the opposite direction of what I would normally expect? So if I normally expect the character to be facing right, if that's what player 1 normally faces, then is flipped would be facing left. But that was convoluted, so I've changed the Boolean to be called is facing left. If you want to do this, you can. You can follow my lead if it's confusing you as well while you're trying to work on it. If you call it is facing left specifically, then you should not have to update any of your logic, because for me, that's is flipped always meant is facing left, essentially. So just so no one's confused, that's what that is. But this is the same logic you guys should be familiar with, where we check if the character is facing left or right, and then we determine if the character is on the opposite side of the opposing character. That way we can automatically flip them when they are. And what we were doing was checking if they had a character mesh, and then if they did, we were changing their scale. Since we now have objects, components attached to this mesh, when we flip them, we also have to flip this functionality if we want it to work correctly. So I'm going to cover that right now. So all this is stuff you should be familiar with, and everything above this is stuff that we covered in other functions, or excuse me, other episodes, as well as this stuff. All right, so the only new stuff in each of these branches for the tick, so either if facing right, or excuse me, if facing left, or if not facing left, which means if facing right. The only new functionality that we've added is this for loop right here that we're doing within the if character mesh if statement. Now, this is really important. These are not the same. You would think, oh, these should be the same. You can just set them to 1.0, -1.0 like we do with the mesh. So the method that we have in here is good, but if you need to have something that isn't a scale of 1.0 or -1.0, then this won't work. And so same with the mesh. If you need to update this for your mesh, if you don't want your mesh to be 1.0 or -1.0, you'll need to adjust this to how I'm doing it here. So let me walk through this. Basically, we do a for loop. This basically is saying we start at index 0, we get all the children components of the character mesh, and then we increment the index every time we go through the loop, so we can actually step through every single child component. I make a temporary hurtbox transform. It gets removed when this for loop ends, when it falls out of scope. And I set the transform to be equal to this. Character mesh get child component at index I. Remember, that's what we're looping through, so we pass that in for the child component. Then we get the relative transform of that. So this has the entire hurtbox transform. Then I make an F vector hurtbox scale. You'll notice this is the same way that we did it for the character mesh, but I'm just doing it for the hurtboxes now. So now I grab the hurtbox scale by doing hurtbox scale equals hurtbox transform dot get scale 3D. And then here's where things start to be different. Since we don't want it to be set to exactly 1.0 or -1.0, we want it to be set to the values that we set in the blueprint. We have to be very careful. We can't set it to just 1.0 or -1.0. Now, the way you do this is for if the character is facing left, we are flipping them. So this is flipping them from facing left to facing back to the right. Okay? You can tell because at the end of the operation is facing left is false, which means they have to be facing right. So to make the character face right with the logic we have set up, we have to do an absolute value on our hurtbox scale. FABS or FABS is float absolute value is essentially what this stands for. The reason we do this is because we don't care if it's positive or negative. We just need the actual scale as opposed to 1.0 or -1.0. So if the scale of this is 0.5, for example, then it doesn't matter if it's positive or negative. We're going to need it to be negative at the end. But we can't just multiply it by -1 because this logic can happen whenever we flip. So if you already had it negative, if you needed a negative scale, and you multiply by -1, it's going to be positive, which is going to be facing the wrong direction for what we want. It's okay if that doesn't really make sense. Just know that, see how I've set the scale of the mesh to be -1 here? We need the hurtbox scale to match that to look correct, but we also want to make sure we're keeping the scale of the actual component as opposed to just a solid value. So we do float absolute value of this and multiply by -1.0. Then we set the scale 3D the same way that we normally do. We grab hurtbox transform, set the scale 3D, and pass in the scale that we modified. Then we grab the character mesh at that child component that we just pulled from and set the relative transform to the hurtbox transform. It's worth noting, to use absolute value, you have to include math.h. I mean, there are some other files as well you can do it with, but to use the one I'm using, fabs, you need math.h. All right. And now let's go back down to the tick function. And now let's do the other side. So this is if we're facing right and we're flipping the character left. It's going to be basically the same method, but the difference is we're going to get the absolute value, and then we're just going to times equals 1.0. And you could actually remove this. You know, multiplying something by 1 doesn't actually change it at all. So you could actually completely remove this. I just wanted to show you, see how the scale was being set to 1.0? Then we also need to multiply by 1.0. Times equals means we're multiplying this value by this value and then setting this equal to the result. All right. Once you have those differences in, then your complex hurtboxes should flip when we flip. So if I skip through all this, reload our level, you can see I have my complex hurtboxes, and they will flip as we flip sides. So it will look appropriate for the mesh and will never go out of sync. And that's pretty much all I got for you today, guys. So I do want to cover one small bug that people brought up to me for last episode, where we did the skipping idle and being able to go back into the same hit reaction. There was a case where if you have specific things done in the state you chose, like I set the state to recovery, which was okay because I wasn't messing with recovery at the time, but I had misspoke and said that you can set it to basically any state that is not related to stun. It's not actually true because, you know, if you have other rules in your logic, it could end up breaking because of that. So long story short, to fix the issue where your character gets stuck after performing the end stun and all the different stun logic we had in the previous episode, all you have to do is make a new anim notify in your mutant anim BP. So specifically on the reaction where the get relevant anim time remaining is less than or equal to 0, meaning that this animation finished and you are returning to idle, not restarting the state, you can, in the end transition event spot, make a new anim notify. I called it return to idle from stun. I've done it on every spot. So low hit reaction to idle, high hit reaction to idle, where it's get relevant anim time remaining less than or equal to 0. And lastly, same with the mid hit reaction to idle. Then in my event graph, I look for that anim notify, grab the event, and all I do is I reset the character state to not moving. I didn't run into the issue just because of the way I had set things up, but it is something I should have been aware of, so I wanted to bring it up to you guys. And my apologies for that. Alright guys, and that's all I got for you today. So thank you so much for watching. If you enjoyed, please subscribe. It does more for the channel and more for me than anything else you can do, and it just lets me know I'm doing a good job and you're enjoying the series.
Ready? Fight.
In the next episode, we'll probably go over multiple hurtboxes, and we'll return to the simple version, because at this point with the complex hurtboxes we have, you could do whatever you needed to. There's not really a need for another episode. If you want to add throws, you just add other mesh components, different things like that. But for our simple hurtboxes, they still need some work to support more than one at a time. So we'll go over that in the next episode, or one of the following episodes, if not the next episode. And then we're going to finish up the input buffering part 2, or excuse me, buffered input part 2, where we convert everything from seconds to frames. If you guys had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. I'll be happy to help you with anything and get you on the right track. And I want to give a huge shout out to my YouTube membership and Patreon supporters and subscribers. Thank you guys so much for continuing to support me. I really appreciate it, and it really does encourage me to keep making these videos better and better. So thank you so much. Once again, that's all I've got. So thank you so much for watching, everyone. And I'm Shawnthebro. I'll see you in the next one. Goodbye, guys.